Welcome to the deep dive. If you've ever been near legacy IT systems, you probably know that sound of technical debt just piling up.
hmm
Today, we're really digging into translating critical code, moving it from one programming language to another.
Yeah, and it's not just a tech task, is it? Our sources frame it more like performing a digital heart transplant on a business.
That's a great way to put it. High stakes stuff. It impacts performance, security, even the people involved.
Exactly. It might sound like just, switching COBOL to Java, but you're fundamentally changing how a big organization operates. So our mission today is to look at the why behind it, the serious risks, and the strategies companies actually use to pull this off.
Right. We're diving into why companies get pushed into this, what the payoff can look like if they get it right, and the different ways they can actually do it. Like, just wrap the old code,
Hmm.
or replace bits,
Hmm.
or the big one, a complete rewrite from scratch.
And it's key to get this upfront. Usually this isn't something companies want to do proactively. It's often forced on them.
Oh, absolutely.
You've got this tension, right? A system that works, that's stable, butting heads with the need to modernize. It's driven by real needs. Maybe the old language isn't supported anymore, or the system just flat out can't connect to newer essential tech.
Okay, so let's break down those drivers. Our sources seem to put them into maybe two main buckets, system problems and people problems.
Yeah, that sounds about right.
On the system side, it's often about making old stuff work with new infrastructure, or maybe they need their program to work on, I don't know, phones or tablets, and the original language just wasn't built for that.
Exactly. And that ties right into the people side, which honestly can be the real killer for these old systems.
How so?
Well, the language itself might be obsolete, like no updates, no community support. Every little bug becomes a potential disaster.
Right. Scary.
But even more often, it's that the company's own team, their developers, they already know and use newer, more popular languages. So the question becomes, why spend a fortune finding, the last few COBOL programmers on Earth?
Mhm.
Why? When you could just translate the system to work with the skills you already have in-house.
Which brings us nicely to that classic example we found in the sources, the bank system update, moving from COBOL to Java.
Perfect example.
Yeah.
Because COBOL, it's ancient but incredibly reliable for what it does, processing massive amounts of transactions. Banks still rely on it for trillions daily.
Wow. Trillions.
But the developers who know it, they're literally retiring. The need to move is becoming urgent.
So the necessity is clear. What about the upside? If they manage this huge shift to Java or something similar, what do they gain?
Oh, the benefits are transformative. We see three main advantages popping up again and again in the research.
Okay, what's number one?
Performance, just raw speed and efficiency. Newer languages are built to use modern hardware better. Think faster processing, much smarter memory use.
And that's not just like 5% faster, is it? It can be a game changer.
Exactly. It could mean processing 10 times the volume in the same amount of time. That completely changes the economics.
Okay, huge performance boost. What else?
Features. Suddenly you have access to all these modern tools, massive code libraries, and maybe most importantly, much, much better security options. Things that didn't even exist when the original code was written.
So you're swapping out old defenses for modern ones. Makes sense.
Definitely. And the third big win is that wider reach, that scalability.
Yeah, getting it onto more devices, reaching new customers.
Right. But it also means it's way easier to find developers, get support, tap into online resources. You go from this niche, maybe one-person maintenance job to being part of the global software world.
Okay, so better performance, more features, wider reach. Sounds amazing. But there's always a but, isn't there?
Oh, absolutely. These benefits come with some really significant downsides and risks. And this is where these projects often get bogged down and just fail.
Right. The first challenge everyone sees coming is just the sheer resource drain, isn't it? The time and the cost.
Huge. And it's not just the translation work itself. It's the absolutely mandatory, incredibly detailed retesting of everything, every single function, every edge case. Plus, you often need to train your current staff on the new system.
That testing sounds brutal.
It has to be, which leads straight into the second big problem. Errors and what you might call semantic drift.
Meaning
The risk that the new code doesn't behave exactly like the old code. Sometimes subtle, vital business logic that was baked into the original system can get lost in translation. Or you just create brand new bugs.
ugh, new bugs are the worst.
Tell me about it. This lack of perfect one-to-one equivalence is precisely why that tested phase is so critical and so lengthy.
But hang on, isn't there a risk that even if you migrate, say, from some ancient proprietary thing to modern Java, you're not really getting rid of the underlying problems, you're just moving the mess to a new platform?
That's a really sharp point, and it connects to the third major challenge,
Huh?
the learning curve. And this hits everyone.
Right, not just the techies.
Nope. Users have to learn new interfaces, maybe change habits they've had for decades. Developers need to get up to speed on the new language. Plus, they need an almost archaeological understanding of the old code they're replacing.
Wow, archaeological. I like that.
And then the organization itself has this massive task of updating all the documentation, training materials, everything.
It really underscores why planning is so crucial, like you said earlier. You can't just wing this.
Not a chance. You have to understand that this translation project sends ripples through the whole company. It affects users, management, and the dev team, all in different ways.
So for users, what's the immediate impact?
Well, the good stuff is new features, maybe better security, more modern feel. But the downside is friction. They need time to adjust, maybe formal training. They have to unlearn old ways of doing things. That resistance can be a real hurdle.
And for the business leaders, the management.
They're juggling the money and the risk. They see the huge upfront cost, the long timeline, and the scary possibility of disrupting services if things go wrong during the switch.
SARS.
Definitely. They're constantly calculating, when does this massive initial pain become worth the long-term benefits, like easier hiring and better tech support?
And then the developers stuck in the middle.
Yeah, their job is intense. They're, like you said, part archaeologist, part architect. They have to translate accurately, keep the code quality high, and document every single decision. Especially the why was this obscure old logic replicated this specific way in the new system?
Finding equivalent features must be tough, too.
Oh, absolutely. Ensuring the new system mirrors the old behavior perfectly is a massive challenge.
And that bank system update, the COBOL to Java one, really shows this tension, doesn't it?
Perfectly. The benefits were clear, faster processing, easier to find Java devs, huge wins for the bank.
But the downsides?
Equally huge. That incredibly long testing period we talked about, retraining all the staff, and just the eye-watering initial cost. It was necessary for survival, sure, but it was definitely not cheap or fast.
So, okay, a company decides they have to do it, they bite the bullet. How do they actually approach the implementation? Our sources mention three main ways, right?
Yeah, three main strategies, each with different risk profiles.
What's the first one?
It's often called the wrapper approach. Basically, you leave the old code running as is, but you build a kind of modern shell or wrapper around it using the new language.
Ah, so you don't touch the original engine.
Pretty much. It's faster, definitely less risky than a full replacement, and it lets you expose the old system's functions to newer services relatively quickly. Think of it like a temporary bandage, maybe?
Okay, a bandage. What's option two?
Gradual replacement. This is the cautious route. You replace small, manageable pieces of the old system one by one, usually starting with less critical parts.
That sounds safer.
It generally is. You can test each new piece thoroughly in isolation. And crucially, it lets the business spread that huge cost over several years instead of taking one massive hit.
Makes sense. And the third one? The scary one.
The complete rewrite. Start from a blank slate in the new language. This is where you can really tackle deep-seated technical debt. Fix all those architectural mistakes made over decades.
Sounds tempting.
It is, but it's also the most time-consuming, the most expensive, and by far the riskiest approach. The potential payoff in terms of a truly modern, resilient system is huge, but so is the potential for failure.
So, wrapper, gradual, or rewrite. Big choices. Does success depend on more than just picking the right path?
Absolutely. Whichever path you choose, success really hinges on following solid best practices throughout the whole project, planning, doing the work, and then keeping it running.
Okay, let's break those down. What's key in the planning phase?
Well, first, really interrogate why you're doing this. Is it truly necessary? Then choose the target language carefully, not just what's popular now, but what will likely still be supported and have developers available in 5 or 10 years. And finally, set a realistic timeline. Build in buffers for surprises because there will be surprises.
Always. Okay, planning done. What about implementation?
Test, test, and test again. That's paramount. Maintain incredibly clear documentation, not just what changed, but why. And train users and staff thoroughly well before you actually flip the switch.
Get everyone ready beforehand, smart, and after it's launched, The maintenance phase.
Yeah, the project isn't really done at launch. You have to treat it as the beginning of a new life cycle. That means constantly monitoring performance, keeping the system updated. And this is important, having a way to get feedback from users so you can fix any issues the change created.
Right. It's an ongoing thing. So if we boil it all down, what are the absolute key takeaways from all this?
I'd say plan meticulously. Think about everyone affected users, the business, the developers. Choose your approach. Rapid, gradual rewrite, based on your actual risk tolerance and resources. Give people time to adjust. And keep your eye on the long-term prize, because that's what justifies all the short-term pain.
That makes a lot of sense. Which leads us nicely into that final provocative thought for you, the listener, to chew on.
Yeah, think about this. When a company is facing that huge cost and risk of a major translation, like moving off COBOL, they're making a fundamental calculation about survival.
Right.
So the question is, at what exact point does the ongoing cost of sticking with the old stuff, finding those rare, expensive experts, patching security holes in unsupported code, at what point does that finally become undeniably worse than the massive known pain and expense of making the switch?
When does the slow bleed become more dangerous than major surgery?
Exactly. It's that moment when the technical debt stops being just an accounting problem and starts becoming an existential threat to the business itself.
A sobering thought, and a perfect place to leave it for today. Thanks for joining us on this deep dive.
See you next time.